For our first lesson in 4.4, we're going to be looking at 4.4a, proportional and non-proportional situations with graphs and equations. And our goal for this lesson is to determine if graphs and equations are proportional or not. Now, in all honesty, this is a lesson that you guys should be able to do even without any video notes. I've talked about how to determine if graphs, equations, tables, all those different things, whether or not they're proportional or not. So we'll take a more, just a quick look at these different types of situations and show how we can determine whether or not they are proportional or not. So to start, a couple things of notes. First note is related to the graph. Second note is related to an equation. So for a graph, when the graph of a linear relationship passes through the origin, the relationship is proportional. So if you have a graph of a line, and that graph passes directly through the origin, through 0, 0, then that relationship is proportional. On the other hand, if the graph of a line passes through any point on the y-axis other than the origin, then it is not going to be a proportional relationship. Similarly, for an equation, when a linear equation does not have a value for the y-intercept, or does not have a b value, then the relationship is proportional. However, if there is any value at all for b, then the relationship is not going to be proportional. So let's go ahead and take a look at a couple examples of graphs that are proportional or non-proportional, and a couple equations that are proportional and non-proportional. So here we have two examples. Example 1, with the red line, we see that the red line passes directly through the origin right here. And so because this red line passes directly through the origin, that makes this relationship proportional. And that is the only thing that we need to worry about, is if the line is passing directly through the origin or not. Okay? So again, in this case, we see that right here, the red line passes directly through the origin, and that makes that relationship proportional. For example 2, on the other hand, we see our origin is right here, and the line is not passing through the origin. Okay, we have the y-intercept here, looks like to be about 3. So because example 2 does not pass directly through the origin, again, it does not pass through directly through 0, 0, that makes it non-proportional. Okay, so again, example 2 is non-proportional because it does not pass through the origin, while example 1, it is proportional just because the only reason it's proportional is because it passes through the origin. Okay, and that's it. That's all we need to look for when we're looking at graphs, is we're trying to determine if the line passes through the origin or not. And again, if it passes through the origin, it's proportional. If it does not pass through the origin, it is non-proportional. Now let's take a look at a couple examples of equations. Alright, for example 3, we have an equation y is equal to 2x minus 1. Now in this equation, if we were to identify our value for slope and our value for our y-intercept, our value for our slope would be 2 over 1, and the value for our y-intercept would be negative 1. Now, the mere fact that we have a value for the y-intercept, because we have a value there, this one is going to be non-proportional. Alright, so non-proportional. Again, the only reason why this is non-proportional is because we have a value of negative 1 back here. This value for our y-intercept means that our equation represents a non-proportional relationship. Now for our next example, example 4, we have an equation y is equal to negative 2/7x. And when we look at this equation, we see our value for m, that's supposed to be an m, is negative 2 over 7. But then when we look for our y-intercept, there isn't a value given. Okay? There is no number that we're adding or subtracting to the end of the equation. So therefore, our value for our y-intercept is actually going to be 0. Okay? There is no given value for our y-intercept. So that's what we're looking for. We're looking for either nothing to be over here behind the slope, behind the x term, and so that makes our y-intercept 0. So anytime our y-intercept is 0, that is going to give us a proportional relationship. And again, the only reason why this is proportional is because we're not adding or subtracting anything to the back of the equation, which means that our value for our y-intercept is going to be 0. Now, if we think about that, if our value for our y-intercept is 0, that means we don't go up or down any units on the y-axis before we place our first point. Therefore, we would place our first point of our graph right at the origin, which brings us back to what we were talking about earlier with equations. If the equation passes through the origin, which if we were to graph example 4, we would see that that graph goes through the origin, and therefore it would be a proportional relationship. Now, one way that the textbook or the online curriculum might try and trip you guys up with these types of problems is you need to have two variables. In both these equations, we have two variables. We have a y and an x. If you're given an equation that only has one variable, if that happens by chance, that's going to be non-proportional. Okay, that's just going to be a single point on a graph if we're just given a single variable. So we need two variables in order to have a proportional relationship. Okay, so that pretty much wraps up our lesson, 4.4a. Again, hopefully at this point you're able to determine if graphs and equations are proportional or not. Again, for a graph, you're looking for it to go right through the origin. For an equation, you're looking for it to not have a value for the y-intercept. If those conditions are met, then it is a proportional relationship. Any questions, write them down. We can talk about them in class tomorrow. Have a good rest of your day.